In this problem, we are to find the maximum vertical distance between the line y equals x plus 53 and the parabola with quadratic equation y equals x squared. And we are to do this over the interval -4 to 3. So to give you an idea what this looks like, I'm going to go to my graphing calculator, press y equals, type x plus 53, enter, and y equals x squared. Now I'm going to go to my window by pressing the window key, and my x-min and x-max are such that I can see the graphs between -10 and 10, which is plenty big enough to see the interval -4 to 3 given in the problem. Going down to my y-min, I might put that at 0. To determine what the y-max might be, you could mentally plug in x equals -4 and x equals 3 into both equations to get an idea how big the y values may be. For x values like -4 and 3, you're going to get y values of 16 and 9 on the parabola. And then for the line, on our interval from -4 to 3, those x values give y values like 49 and 56. So on the calculator, I'm going to put my y max a little bigger than 56. In fact, I'll just type in 70, so that when I press graph, that'll give plenty of room in the window to show me what's going on. Since I intend on screenshotting this to explain the problem, it's bothering me that the y-axis has all those thick tick marks. Press window and I'll show you why that's happening. Your y-min and y-max are from 0 to 70, which means there's 70 units of length on the y-axis, and your y-scale is 1, telling the calculator to put a tick mark every 1 unit. Since your y-axis is 70 units long, you're getting 70 tick marks graphed on the calculator. Changing this to 10 would give a more reasonable spacing on the y-axis. In fact, let me press graph and show you that now, between any two tick marks, there's 10 units of length. In fact, from 0 to 70, putting a tick mark every 10 units, you'd expect to see 7 tick marks, and I do. I'm going to make a screenshot of the window of my calculator and use that screenshot to explain what's going on. First, notice that since we're trying to find the maximum vertical distance between the two graphs, for x values between -4 and x equals 3, that's between this x value here and this x value here. So we're actually looking in this region between the line and the parabola, and our job is, if we were to draw a vertical line anywhere in that region, we are to find the line that has the greatest length, because that line would represent the distance between the two graphs. Notice if I draw the vertical line further to the right between the line and the parabola, that vertical distance is much greater than the one on the left. But I'm going to use the line on the left to write an equation for the distance of any vertical line between the line y equals x plus 53 and the parabola. Let me point out, if I was to label this point right here on the line, instead of labeling it x comma y, you could label it as x comma x plus 53, since the y value literally is x plus 53. And notice that since the y value of a point gives you the distance above the x-axis, this distance that I'm drawing right here would have a distance of x plus 53 units. A similar argument can be made if I was to plot this point on the parabola. Instead of labeling it x comma y, I could label it x comma x squared, since y is equal to x squared. Likewise, since the y value of a point gives you the distance that the point is above the x-axis, this distance right here could be represented as x squared. Now, to find an equation that represents the distance of the vertical line, I argue that since the large distance is x plus 53, and this gap in here is given by the expression x squared, then I can subtract the large minus the small to get that distance of the vertical line to be x plus 53, which was the large distance, subtract off x squared, which was that small distance down here. So back over here, I'm going to say the distance is x plus 53, subtract x squared, and my job is to find the maximum distance, d, on the given interval, and to do that I'll use my graphing calculator again. I'm going to go to y equals and clear the old equations and replace it with x plus 53 subtract x squared. And when I graph this, I'm going to get another parabola, but it'll be different than the one we had graphed before. In fact, when I press graph, you will see you're now getting a parabola that opens down. It has a maximum right there just to the right of the y-axis, and I'm going to use the full accuracy of my calculator to find that maximum by pressing second, trace, scrolling down to the maximum feature, number 4, pressing enter, and then a good left and right bound would be -4 and 3, since that was the interval given in the problem. So I'm just going to type -4, enter. I'll press 3, enter as a right bound, and then when it asks for a guess, I'm just going to press enter and enter that same x value of 3 as my guess. You can pretty much pick any point between the two vertical dashed lines as a guess, but it won't change your answer. I'm getting that if you pick a point on the line on the parabola whose x value is 0.5, that you will get a maximum distance of 53.25 units. So our result is saying, given that this is x equals 1, somewhere around a half, which is about right here, this would be the point whose x value is a half, and it would be the point that if you connected a vertical line between the line and the parabola, the length of that line would be the maximum possible in the interval from -4 to 3.